Hello student, I hope you all are doing great. In this video, I will talk about how to make the full wave rectifier. So first, I will talk about the rectification, the process in which alternating current is converted into direct current by using one or more than one diode is called rectification. So let's see how to make the full wave rectifier. The basic component we need to form the full wave rectifier. One is transformer. Second, we need two diodes. One, we need capacitor. One LED. Second last, breadboard. And last, some connecting wire. So let's see how to make it. So firstly, I will just connect all the components on the breadboard according to the circuit diagram. At the positive terminal of both the diode D1 and D2, they are connected to the yellow terminal of this transformer. First diode just connected with this wire, and second diode is connected with this wire. And the negative terminal of both the diode is just connected to the positive terminal of the capacitor, and then positive terminal of the capacitor further connect to the positive terminal of the LED with the resistor, and the negative terminal of both the LED as well as the capacitor, they are connected to the middle wire of this transformer, and here the middle wire of this transformer is a blue wire. So let's see how to assemble it according to circuit diagram. Before assembling the circuit diagram, so first I will talk about the breadboard. You can see the lot of the points on this breadboard, and the points in the columns, they are interconnected to each other, but the point along this row, they do not connect to each other. You can see the one strip between this breadboard, the point on this left side of the strip is not connected to the point right side of the strip. It means if I want to just connect this capacitor on this breadboard, then I will just connect like in this way. If I want to connect the capacitor between this breadboard, then I will just connect like in this way. But now if I want to connect this capacitor to the left or right side of the breadboard, then I will just connect the capacitor like in this way, because these column points is not connected to these column points. So now connect the first diodes on this breadboard. So you can see the silver ring on this diode. The terminal of this diode is connected to the silver ring, act as the negative terminal, and this terminal of this diode act as the positive terminal. So first I will connect the diodes on breadboard, and same I will connect the another diode on the breadboard. So now next I will connect the transformer to this diode. The yellow wire is just connect to the first positive terminal of this D1, and the second yellow wire of this transformer is connect to the second diode, positive terminal D2. So now connect the negative terminal of both the diode to each other. I will connect this diode with the help of connecting wire. So this is the negative terminal of the capacitor, and this is the positive terminal of the capacitor. I will just connect here. And the negative terminal of both the diodes is just connect to the positive terminal of the capacitor according to circuit diagram. And the positive terminal of the capacitor is further connect to the positive terminal of the LED. I will connect LED like in this way. and the negative terminal of the LED is just connect with the resistor, one terminal of the resistor, and second terminal of the resistor is connect to the negative terminal of the capacitor, and negative terminal of capacitor just is connect to the middle wire of this transformer. So our circuit is completed, so let's check it. Then you can see the red LED glow. It means our connections of the circuit is correct. So let's explain it working. So now when I just positive half cycle of AC is fed to the primary coil of this transformer, and due to the mutual inductance, the first terminal of this secondary coil just act as at the positive potential, and the second terminal of this transformer at zero potential, and third terminal just at the negative potential. So due to the positive potential, the diode D1 just act in forward bias, and the diode D2 just act in the reverse bias. So we know in the forward bias the diode offer the low resistance, and in reverse bias diode offer the high resistance. It means the electrical current easily pass out the D1 diode, but no electrical current is passed through the D2 diode. So the pulsating voltage is obtained at a point P due to the D1 diode. You can see. Again, now when I just fed the negative half cycle to the primary coil of this transformer, due to the mutual inductance, again the polarity at the D1 diode is changed. So the terminal first of the secondary coil just act as the negative potential, again second terminal at zero potential, and third terminal at the positive potential. So due to this, the negative potential at the terminal 1 is just connected to the positive terminal of the D1. It means so the D1 just work in reverse bias and D2 work in forward bias. Again in the reverse bias they offer a high resistance, and in forward bias they offer the low resistance, and the electrical current is easily pass out through this D2 transformer. No electrical current is pass out the D1 transistor. It means at the point P, again the pulsating voltage is obtained due to the D2 diodes. Now when I just fed the continue AC supply to the primary coil of this transformer, the continue pulsating output is obtained across D1, D2, D1, D2, so continuously. So this pulsating output voltage I am not using in practical purpose. First I will convert this pulsating voltage into pure DC voltage with the help of this capacitor. The capacitor just acts as the filter. It blocks the DC voltage because it offers the high resistance to the DC voltage, and so the DC voltage obtained across this capacitor just appear on this LED, and LED is just glow. So this is the working about the full wave rectifier. So thanks for watching.